Hello dear students, in the previous session we have studied the finite Fourier sine transformation for solving wave equation, and this was a final result we have got. U of x comma t is equal to 2 by L summation n is equal to 1 to infinity fs of n cos n pi c by L into t plus L by n pi c g s of n into sine of n pi c by L into t. Here fs of n is nothing but integral over 0 to L f of x sine n pi by L into x dx, and gs of n is nothing but integral over 0 to L g of x sine n pi by L into x dx. Okay, so now we will solve the wave equation using finite Fourier cosine transform. Okay. This is your problem. This is the wave equation. We all know that. This is the initial condition they have given, and your domain is set for 0 to L, which is nothing but finite values in your domain. Okay. And the boundary condition is ux of 0 comma t equal to 0 and ux of L comma t is equal to 0. In the previous session, I have told you, in order to find out whether we are supposed to use finite Fourier sine transform or finite Fourier cosine transform, this is the condition you have to verify. If this condition is true for your boundary condition, then you are supposed to use finite Fourier sine transform. If your boundary condition does not hold, means you should use finite Fourier cosine transform. So in this problem, this boundary condition, for this boundary condition, this condition will not holds good. So I will use finite Fourier cosine transform. You can check that. We know that for equation 1, the first step is I have to take finite Fourier transform on both sides of my equation 1, isn't it? So let's take that. This is the solution. If I take finite Fourier cosine transform on both sides of my equation, using the formula, I can write this as, using this formula, if I apply finite Fourier cosine transform to my equation 1, I will get this. Okay. F dash of L is nothing but dou u by dou x L comma t. F dash of 0 is nothing but your L, here x is L, here x is 0. So from your boundary condition, that is equation 4 and equation 5, you can write directly that this is tends to 0 and this is equal to 0. So what will happen now? Dou square uc of n comma t by dou t square is equal to minus n square pi square c square by L square into uc of n comma t. I can write this as dou square uc of n comma t by dou t square plus n square pi square c square by L square into uc of n comma t. This c represents you are using cosine transform, right? That's why that c is there. If you are using sine transform, means you should write s there. Okay. This is equal to 0. So now using auxiliary equation, I can write this as m square plus c square n square pi square by L square is equal to 0. So if I find out the root for this, I will get m is equal to plus or minus I into c n pi by L, isn't it? So now let's write the solution. uc of n comma t is equal to a of n, which is nothing but your constant, into cos c n pi by L into t plus b of n into sine c n pi by L into t. I will call this as equation number 6. What is the next step? You have to take inverse finite Fourier cosine transform on both sides of your equation 6. Before that, let's take finite Fourier cosine transform to your initial conditions. so that you can substitute that in your equation number 6. So if you take finite Fourier cosine transform to our initial conditions, you will get, I will write it directly, UC of n comma 0 is equal to f of n. If you substitute this in your equation number 6, you will get fc of n is equal to a of n. Why? Because if you substitute t is equal to 0 in your equation number 6, cos 0 is 1 and sin 0 is 0. So you will get a of n. So now what you have to do? You have to differentiate your equation number 6. If you differentiate your equation number 6, you will get dou uc by dou t is equal to minus cn pi by L into a of n sine of cn pi by L into t plus cn pi by L into b of n into cos of cn pi by L into t. So now take finite Fourier cosine transform to your equation number 3, then substitute that in this equation. Here you have to substitute that. Okay, let's continue further. I have take a finite Fourier cosine transform to your equation number 3, that is your initial condition. So you will get dou by dou t of uc of n comma 0 is equal to gc of n. Now you have to substitute t is equal to 0 in this equation. So if you substitute, this whole term will be equal to 0 since sin 0 is 0. You will get cn pi by L into b of n into 1. So you will get gc of n is equal to b of n into cn pi by L, which is nothing but, if you write it for b of n, you will get L by cn pi into gc of n. I will call this as equation number 8. Now substitute your equation number 7 and 8 in your equation number 6. Let's substitute now. UC of n comma t is equal to fc of n into cos cn pi by L into t plus L by cn pi into gc of n into sine of cn pi by L into t. Okay. Now what is the next step? You have to take inverse finite Fourier cosine transform on both sides of this equation. If you take inverse, you will get u of x comma t is equal to 1 over L fc of 0 plus 2 over L into summation n is equal to 1 to infinity into fc of n into cos cn pi by L into t plus L by cn pi into gc of n into sine of cn pi by L into t multiplied with cos n pi by L into t. This is using your formula. I have written that what is u of x comma t, as we did in the previous problem. Okay. So now there is a value for fc of n and gc of n as well as fc of 0. Okay. So since our final equation should be in the form of x and t, here it is still in n. You can observe that. So we have values for fc of 0, fc of n and gc of n. Fc of 0 is nothing but integral over 0 to L f of x into dx. Fc of n is equal to integral over 0 to L f of x into cos of n pi x by L into dx, and gc of n is equal to integral over 0 to L g of x into cos n pi x by L into dx. So if you substitute these values here, your final solution will be in terms of x and t. Okay. This is the final solution of your wave equation using finite Fourier cosine transform.